All right, guys, welcome to today's episode where we will be talking about ATP synthase. Perfect. All right, so just to start off here, we're going to assume, we've already talked about the majority of the electron transport chain. We've talked about complexes 1, 2, 3, and 4. And now we're going to be talking about complex 5, which is ATP synthase. And so we know that in complexes 1, 2, 3, 4, that is a process where essentially NADH transfers electrons to QH2, which then transfers electrons to cytochrome C, which can then carry electrons to complex 4, in which O2 is going to be reduced to H2O, all right? And so just keep that in mind and know that while all of this is happening, protons are being moved from the matrix to the inner membrane space. So in complexes 1, 3, and 4, we have protons moved from the matrix to the inner membrane space, and depending on how many oxygens are reduced, we're going to usually either have 10 H pluses, 10 protons moved, or 12. And so let's jump into it. So like I was saying, this is what happens afterwards, okay? So ATP synthase, we see we've got these two different subunits. We've got this F0 subunit, we've got the F1 subunit. We're going to break those down. Essentially, the F0 subunit is what helps us to move these protons back across from the inner membrane space to the matrix, which helps us to drive the ATP synthase. If we were to move them from the matrix to the inner membrane space, it doesn't generate enough free energy to drive the phosphorylation. I guess it's just right here, phosphorylation of ADP and inorganic phosphate to ATP. So to be able to generate enough free energy, we need to move these protons back this way from the inner membrane space to the matrix, and that's called proton motive force. And that is the amount of free energy to drive that ATP synthase, okay? So F0, that allows us to move those protons. F1, this is essentially the catalytic part of ATP synthase where the good stuff happens. Let's jump down here. We've got the alpha subunit. We've got these C subunits. Let's talk about them. The alpha subunit, essentially, it's just there in the membrane. It's anchoring these C subunits down here in the membrane. Not doing much. As we can see here, it's allowing some of these protons to be moved back to the matrix side. So the alpha subunit, it's going to help in that sense of moving those H pluses back. And the C subunits, as we can see, they rotate. And so the C subunits, they have aspartate and glutamate, which have those carboxyl groups. And these protons actually, they bind with a carboxylate group, they neutralize it. That causes this to rotate, as we can see. When it rotates, it brings another C subunit into place to bind another proton, and then it actually causes this proton to be released as well when it shifts. Okay, and so a closer look here. We already talked about the alpha. We talked about the C subunits. The C subunits are attached to this gamma subunit that we can see in here. The gamma subunit, that will rotate with the C subunits. That is attached to these alpha and beta subunits. The alpha subunits, they just anchor the beta subunits. They don't actually do anything catalytically. The beta subunits and alpha subunits actually don't move either. It's these C subunits moving with these gamma subunits attached to the alpha beta subunits that cause conformational changes that then allow ATP synthase, essentially. So we're going to be super quick here. There's an open state, tight conformation, and a loose conformation. Open conformation, When we get there, the ADP inorganic phosphate, they come into that open conformation. In the loose conformation, they bind with the active site, but they're not producing ATP yet. In the tight state, ATP is actually synthesized. And then in the open state, the ATP is released again. So open state allows that initial binding, and it allows for the ATP to be released. And these are conformations that are found in the alpha beta subunit, but just in that beta subunit is where that catalytic activity is occurring with the ADP inorganic phosphate coming into the open conformation, combining with the active site in the loose conformation, and then producing the ATP in the tight conformation to then be released in the open conformation again. And that is all we're going to talk about today, and that is our source right there.